Following on from yesterday's video, I thought I'd do a quick introduction to passive solar design. So what is passive solar design? Passive solar design is a method of designing a home so that you can use the heat from the sun to passively heat the house. Passively means that once the house is heated, is designed in a certain way, then the sun can provide for most of the heating necessities of the home. You need a backup heating system, but in like Mediterranean climates and places where it's not too cold, you could essentially have your home heated for free by the sun year round without any need for backup if it's designed properly. So how does it work? Here in this picture you can see that what we want is in the winter when the sun is lower in the sky, we want the sun to be able to enter into the building to heat up the mass of the building, that is everything that is inside the building. So why do we want to heat up the mass? The mass of the building acts as a storage for that heat. And so when at night time, when the sun goes down, what happens is the heat that is stored inside the mass wants to go somewhere. And so for passive solar design, what we need to do is insulate the exterior of the building, not the interior of the building. If you insulate the interior of the building, then you lose all of the mass. Essentially, you don't lose it, but you lose the capabilities that it has of absorbing the heat to then let it out. So if we insulate the exterior of the building all around, so we insulate the roof, the walls, we insulate underneath the slab, the heat only has one place to go, and that is up into the living space. So temperature, heat always goes from hot to cold. So as the sun goes down, so the sun in the day heats up the mass inside the building. The sun goes down at night, and what happens? The temperature of the air inside the building goes down. So then the heat that is stored inside of the mass wants to come to equilibrium, and it comes out of the mass and into the living space. Okay, so those the basics of it is you want the sun to be able to come into the house and heat up the mass, so that then the mass can release the heat into the living space. If you don't insulate the house, what happens is the heat, instead of rising up into the living space, gets lost into it goes outside, because the temperature will be colder on the outside. It will go through the walls, and it will be lost to the outside. That's why it's so important to insulate your buildings. Okay, so the thing that we can see quite clearly on this image is as well what happens in the sun in the summer and the winter. So in the winter you have the sun at a lower angle, comes straight into the house via the glazing, which is on the south face, and I'll get into this a little bit more in a second. In the summer, the sun is higher in the sky, and so what we do, so that the sun doesn't still come in and heat up the space, which isn't what we want, we make these little overhangs. This one's quite big. It doesn't have to be this big. You'll see in a moment. Small overhangs. You calculate the size of the overhang depending on where you are in the world. So the higher sun doesn't come into the building. So passive solar design, if done properly, gives you a nice warm environment to live in the winter, and a nice cool environment in the summer, because also you've super insulated, or at least insulated, the outside of the building. So that stops the transfer of heat, which goes the other way in summer. Because the outside is hot and the inside is cold, you'd get the roof, for example, would heat up, and that heat would radiate into the building. making the inside of the building very hot. And then if on top of it it's so badly designed that the sun can come straight in the summer and heat up the inside, then that just turns into a furnace. Some examples are these big modern houses with enormous windows on the south face that then need thousands of euros spent every month on air conditioning because it's literally a greenhouse. Okay, enough of that. So we will go into SketchUp, which I also spoke about on my last video, and I prepared this model of a small house. There's a few things to take into account when designing, when using passive solar design. You need the first thing is the orientation of the building. The building, or at least the majority of the solar glazing, the building should be oriented as close as possible to true south. That's not magnetic south. Magnetic south is where the magnetic poles are, and they move. They're constantly moving. That's to do with the magnetic field of the Earth. What we want is true south, and that'll become apparent in a second. So after you've oriented the house to true south, then what you want is a certain percentage of glazing on the south face. You want most of the glazing on the south face because this is where the sun will come, the path of the sun will come this way and shine into the house. Okay, you want very little glazing on the east side where the sun comes up, and very little glazing on the west side where the sun goes down. This is because when the sun comes up and goes down, obviously it's lower in the sky, so the sun maybe would come in the winter, maybe rise here and go down over here. In the summer the arch is a lot more pronounced. But in the morning and the evening, when the sun goes down, obviously the sun is lower in the sky, so it can shine directly into the house at whatever time of year. That means if you have big windows on the east and west side of the house, then what happens is you get overheating in the summer. In the summer period, you get overheating because the sun can come directly in these windows and heat up the house. Okay, so let's just go in. Oh, the percentage of glazing. So how big can I make my windows? A really easy rule to follow is you want 7% of the floor space, the total floor space. I've made this house 10 by 10, so that's 100 square meters. So that means that your solar glazing, which is the glazing that goes on the south face, should be 7 square meters. Here I've made these windows 1.25 wide by or high by 1 wide. There's 4 of them, that makes 5, and then you have a glass door which is 1 by 2, so that's a total of 7%. That's 7 square meters, which is 7% of the total floor space of this house. Why 7%? 7% is generally taken up by the mass of the house. It means that the building materials that the house are made of is enough mass to be able to store the heat that is coming through that percentage of windows. Now you might think, well, isn't bigger better because I'm letting more sun in, so it will heat? Yes, in theory, because you let lots of heat in. What happens is that you get overheating. It's too hot in the day, and then glass also loses quite a lot of temperature. Even the new insulated windows lose quite a lot of temperature. So what happens is you will get big temperature spikes where in the day it'll be very hot in there, almost too hot, and at night time the temperature will go down very quickly because we're losing a lot of heat through the windows. So this 7% rule is very easy to follow, and generally it's known that this works well. Let's go inside the house and I'll show you this feature of Google SketchUp. So I'm going to position the camera here in the corner, of this house, and then we're going to look around. Okay, and now we can use this great feature in Google SketchUp. I've set the geolocation, which if you want to set it manually, you go to model info and then set manual location, and I've put my location as Mallorca, and then latitude and longitude. You can find this out on the internet. It's very easy. Set the location and then make sure you set your time settings. Okay, so here this great feature allows us to see what the sun path is going to do in the summer, well, all year round, sorry. So let's go to the depth of winter, where we want a lot of sun in the building. And so with the 7% of solar glazing, if here I'm just changing the time of day, so this is sunrise about 8:13, and you can see the pattern of the sun already coming through the door, and that starts heating up the mass. So because this is orientated directly to the south, we're going to get sun all day here in December. You can imagine how nice it is to live in an environment like this, where in the depths of winter on a sunny day you have loads of light flooding into the building, making it lovely and warm, and a great environment to live in. Okay, that's December. Let's leave it at noon and see what happens during the rest of the year. Now I'm going to move the months control over here, and so we go January. You can see that as the sun gets higher in the sky, less and less light comes into the building. February, March, April, and at about May, you can see on these two windows here, I've set an overhang on the outside so that is stopping this light from coming in. We want that. As of about May, it starts getting very, very hot here, and so we want as little light to come in as possible. You see, July, August, sorry, we're in September. So you can see on these two windows where I put the overhang, no light comes in at all to heat up the building in the hottest months. As the period gets cooler, you can see, and as the period gets cooler, so we're into September, October, autumn, then the sun starts coming back in to heat up the house. Now, I've put these big windows on the side here so that you can see what happens. Let's see. You can see what happens here. Okay, so you see this shadow here, this big light patch here. It's from this big window here. So if we go to August, here we are, we're in August, and look what happens over here as well. Here, this is from the window on the east side. So this is the west side, this is the south side, and this massive patch of light here is from the window I put on the east side. So look what happens. It's August. It's 40 degrees anyway. So, well, okay, I'm exaggerating. It's 28 degrees. This is centigrade at night. It's really hot anyway. So now the sun's coming up, and what happens? Through your east window, you're getting a load of light. Yes, we have shutters, so we can close those, but this is why you don't want to make windows that are too big. So, sun comes up. Look, we have sun coming in for at least a couple of hours in the morning, which is already heating up the building. Because your building is insulated, that heat is going to stay in the building. You can open the windows, obviously, but the outside temperature isn't much better because it's boiling out there. So you get a little bit of sun coming in, you can see here from the windows, but not very much. And mainly on the windows that don't have the overhang, which they would have an overhang anyway if you designed the building properly. And so you get, as of 2 o'clock in the afternoon, almost 3 o'clock, look what happens. You're starting to get sun coming in the west side of the building. So that's going to start heating your house up. Yeah, this is going to heat your house up during the day. This is the reason why we want as little glazing as possible on east and west, and no glazing on the north because it lets a lot of cold in. In a climate like the Mediterranean, you can have some glazing on the north. It's not a problem. It's not too cold, and you can get something like triple glazed windows, and then that would work. That would work well in a Mediterranean climate. It wouldn't let too much cold in the winter. It's not very cold here anyway. So, yeah, okay. So you can see now the main concepts. Oops. Okay, let's just turn this off. So you can see the main concepts now. Here you can see these small overhangs that I put. So this is just a basic design that I put together so that you can see how passive solar design works. Okay, so the main concepts are orientation. You want the house to be oriented as closely as possible to south. Now, if your house is, or at least most of the solar glazing, if your house is oriented in a different direction and you can't get to south, then that's just bad luck. But it's something to take into consideration when you're looking maybe at buying a house if you want to redo it. I live in a house at the moment that is lovely in the summer because it's cool, but it's absolutely horrible in the winter. It faces east to west, so that means that we get no light at all in the winter. No matter how much of a nice day it is outside, we get no light at all. So you really don't want to live in a house that faces east-west, or at least that doesn't have the main windows on the south wall. Okay, so yeah, I think that's it. So the most important things: orient your house to as close to true south as possible. Put the majority of the solar glazing, or all of the solar glazing, on the south wall, and go up to 7% of the wall. If you go with more, you will get overheating if you don't add more mass. Adding more mass means that you'll have to make the windows, the walls thicker, or maybe a nice thick slab if you're building the house from scratch. Minimize the windows on the east and west faces, even though obviously you can put shutters on those and close those in the summer. It's quite nice, I suppose. In the winter we have a similar setup to this, where we have small windows on the east and west, and we'll just keep them closed in the summer. So minimize the glazing on east and west faces, and if possible put no glazing on the north side. I mean, unless you've got rooms that are on the north, and if you've designed your house properly, those rooms shouldn't really be living spaces. They should be storerooms and things like that, because it's not the nicest place to stay because it's dark. And yeah, I think that's it. Google SketchUp is a really great program to use to design your house. It's very, very easy to use. I knocked this little plan up in about 5 minutes, and it's very, very simple, very intuitive. There's only these few little tools up here, so you can see with these few tools you can do so much. If you are interested in learning more about passive solar design, then I learnt everything I know about passive solar design from this book, The Solar House. It's a great book, very interesting read. You can get it on Amazon, or maybe in a bookshop in the UK or something like that. And then an app that is really useful is this Sun Surveyor. It costs maybe $3 or something, so it's not even worth worrying about. This will show you the angles of, so you select where your house is, or anywhere that you want, anywhere that you are or want to see solar details about, and lunar details, and it will plot any day of the year for you in these different kind of maps. It even has an AR view that you can use with the camera of your phone, which will show you quite accurately where the sun comes up and where it goes down. Here you can see an example. That's not the one I wanted. Here you can see an example of a screenshot. It's a really great program. So say you live there and you want to see, it tells you the angles, you know, so sunrise angles, midday and all that kind of thing. It's a really great program for this kind of thing. You can make little maps and send them to your friends or clients or whatever. I really like it. So that's it. I think we've yeah, SketchUp is free and you can download it from SketchUp. I think it's sketchup.com, if not just Google it. But yeah, that's it. So the Solar House, it's a great book on this topic, and Sun Surveyor is an awesome little app for your phone, which helps a lot. Okay, I hope this helped you. If you have any questions, you can always send me an email or write something in the comments down below. I'm not an expert on this by any means, but I have some knowledge on it, and I've used it to design the house that I'm building at the moment. So I hope this has helped you, and thank you for watching.